Yeah. So now we have this and we are good to go. Now, one thing I want us to do is instead of us always doing it in the manual way, I wanted us to I want us to build a function so that the function is actually going to take, you know, the data for us and we don't need to be manually doing it. So we want to build a function which is actually going to, you know, which is actually going to say that we just provide the ticker, the start date, and then the end date, and it will just go and fetch data for us. Simple. So let's do that. So let's build a function. Let me see. Build a function to fetch stock data from Yahoo Finance. And then you know how to create functions, right? So then let's call the function actually get stock data. And then the function is actually going to take three parameters. Let's call this one ticker or tickets. So you provide a ticker or the tickets, that is the company you want to, and you provide the start date, you provide the end date, and that's all we need from you. So when you provide that, the first thing we want to do is to actually, let me use try and error, try and accept, which is a very good thing. Try and accept helps you not to break your code. So it is more like try this. If it doesn't work, return this to me. Simple. You should always run the codes. So I'm going to say that try this thing if possible. So now let's download the data. So yf.download, and then I'm going to say so it should download the tickets you actually provide. That is the ticker, the symbol you provide here, you should pick that. If you provide one, you should pick one. If you provide two, you should pick that two. And then the start date is actually going to be that. Um, so let me make it this way rather to prevent ambiguity. So I will say that tickets equal to tickets so that it wouldn't worry so much. And then start actually equal to start date. That is the date the user provides. And then end actually equals to end date. So we're saying that if you fetch this particular data, we want you to um, save it in a variable called stock data, or let's just say data. Yeah. So store it in a variable called data, and we want you to return. Just mind you, always. So we want you to return that stock that data rather the data dot head. Just give us the first five rows of the data set. So we this is what we want you to do. That is if it works. So if this doesn't work, then that is where the accept. I don't know why I keep typing accept, try and accept. So if accept, then that is if what is given above here does not work. If this does not work, if there is an error here, provided we gave a wrong information or something like that. So we're saying that accept. So this is how we do the accept. So accept, that is if it doesn't work, exception. So I'm saying that exception as E, like it's a way to tell that, you know, um, take the error which you are going to throw to us, that is the exception, and keep it as E. You know, store the error as E. It's just like saying import pandas as PD, or something like that. And we want to print that error. We want to say that we want to print to the user that an error occurred, right? and then we want to provide that particular error. So the error E. But we want to make sure that the error is actually, what if it is a number? So we want to just say that um, the error, whatever the error is, you should format it as a string so that we don't get any future, you know, um, problems. Then after that, we want you to return, so after providing the error, return, nothing. Just provide the error. So we have our data set, and we have our function, sorry, and let's run it. So let's try it and see. So let's do get data, and then when we do get stock data, and for example, let me try. So the stats or the tickets is actually, so you can see that when we hover, you can see it has actually given us the next thing too. So the tickets. So let's say the ticket is actually, I want app ABP. Okay, we did Apple before. Let's try Google. Please provide it in capital letters just like you see on the site. And then the start date is actually, I want it to be the start of the month, 2023, 01, 01, actually. And then the end date, I want it to be, the reason why I'm not saying start is equal to y is because we have only three um, parameters, and I'm making sure that I provide them in the right way because we created the function, so we know what. So let me say up to December, maybe 14th. Yeah. And let me run this and see if it works. So now you can see that boom, it works. And we've had, the data set here. So it has actually shown us the first five observations, just like we did here. It should show the first five observations. So if I probably do data is equal to this, then um, if I do data.shape to see the shape of the data set, you can see that it is actually 5 by this thing because we did return data.head. So if I clean the return data.head and actually say return data, and I do this dot shape, you can see that we have 239 data sets or entries, and then um, 6 variables. So if I do, or maybe if I come down here and I do data dot head, you can see the first 5 here. And the same way, if you do data dot tail, you will see the last 5 observations. You can see the last date is actually 13th of December. That was 2 days ago. And this is the price, the opening price, and those things. That's cool. So you can actually give it a very long range, and it will fetch you the data if you want. So we've successfully built our function. Now, one thing I want us to do we've never done before is to, right now, let's say you built the function, but what if someone else comes and then wants to use let's say your coworker, and he wants to use your function, and he doesn't have this code to see that, okay, this is how you built the function. And you tell him, oh, the function I created, I saved it in Python, so you can just do from this, import this, and then use. And you you tell the person that the thing is called get stock, data. You see, when we want to know much or how to use a function, you just call the function name, like for example, get stock data, and you end it with a question mark, and it will open the helper function for you. Now you can see that there is not it says that there is no doc string. So the doc string is actually the information you give to the user. So what information are you giving to the user? What information are you giving to the user? So that information is actually what is the doc string. And this is how we can actually add doc string to functions. It is always a good thing. It will help you even in the future. So not just comments, but this is a special comment we add in the function on how to maybe probably use the function or something like that. So um, to add a doc string, you just after defining the function, always you add it before you add the body of the function. So like here I come, and then this is how we add it. You add three, you know, that is three opening quotes, double quotes, and then three closing quotes, and then you separate them, three here, by like this, and in between them, you provide everything in there. So you see when you start typing, everything will turn red, telling you that yes, this is actually a text. So Python will see it as a doc string, and it will not add it as maybe a function or something to the or codes to run to get you error. So let's write something. So let's write the use. So let's say use it, and let me underline it nicely. And let's say that fetch historical stock data for a given ticker, symbol and date range. So more like give us a distance, and then let's look at the parameters. The parameters are what you supply to the function, and this one, let's format it very nice. I always like to format my codes, and the first one is actually the ticker or the tickers. So the tickers, it is actually um, string. You get it? So and then this is um, ticker symbol or symbols. That is if it is one ticker symbol or symbol of the stock or stocks, meaning it can be one or two tickets. So of the stock, and then let's give an example. Example is actually something like APPL for Apple. Yeah, let's say for Apple Inc. That is Apple Incorporated or something. And then the next function is the stats, or to differentiate the tickets from the listing. Let's add a listing in the beginning like a dash, so that we will know that this is. So the next thing is the start date, and it is actually a date, and the date format is it is actually a date, and then that is start um, date in the format. So we want to show the user what to do. So month, month, day, and then we go. Now the last thing is let's do the end date. That is also a date, and then it is actually end date in the format. Let's go and copy this guy because it's the same thing. Um, so then let's tell what it returns. So let's say that it returns. So what it will return to you. So let's say that it will return a pandas data frame containing um, historical stock data. So don't worry, I sat down to think of this before writing. So if everything works well, let's see, let me separate this guy. And if I run this, and if I come and run this, let's see whether everything works. Yeah, everything works well. So now if I come and do the helper function, now you can see that, yeah, boom, you can see usage, fetch historical, blah 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 blah, and these are the parameters, what it returns and everything. So now everybody can actually, read and then know what our function is like. So today we've seen how to write a function to grab data from Yahoo Finance, and also to add how to add doc strings, doc, then string as string. That is the helper functions or the helper text you give add to a function to help you yourself and other programmers understand. Now let's go. Let's move forward. So we've had some data here. The next thing to do is maybe let me get Microsoft. Or let me get Meta. For me, I like Meta to be honest. And let me increase the this thing instead of 2021. Let me do 2022 so that it will kind of increase. When you build a function, you can use what you want. I'm going to use Microsoft MFST, and then now we can see that the data set has increased. It is now 490. Maybe let me send it to maybe 2020 so that we get more data. So you can see 995, and then if I do dot still for Microsoft. So we have our data sets. Now let's look at how to um, explore the data sets. So let's do some EDA. So now um, let's try to plot some. Let's try to plot some line charts of the 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 data sets, and then we see how nice and beautiful it is. So let me use. I'm going to use plotly to do. So px dot line, and the thing we're going to give is a data set. So we're going to use data. So data set or the data frame is actually data, or we can say data frame is equal to data. And I want to just plot not all the data sets, all the variables, but I want to plot the open and then the close. And the next thing I'll do is I want to add a title to it. I'm going to say that title equal to distribution of open and close prices. And all I'll do is fake the show. I hope I don't get an error. It's gonna take some time, but we will get. Plotly takes some time to visualize, bring its output, but it's always beautiful. I actually didn't get anything good here. Probably let me run it again and see. It should actually give me. I think it's from my machine. The machine is quite well. It's busy right now. The machine. If I don't kill this machine will kill me. I am always stressing it. It's been on. So it's saying it's not going to give me the values, right? So let me copy this guy and create another. Maybe paste it in there and then show. Come on, let me refresh. and let's see whether it will work. It's still not showing me what I want to show. You can see it has plotted when I even hover, I get the thing, but I don't know what is happening. This is weird, bro. This is really weird, but it will come hopefully. I don't know why it is. I think it's from my machine. This is very strange. I've never seen this before. Maybe the CPU. Let me check the CPU. I use it of my machine CPU. Probably I did something to it. So let's see my CPU usage. You can see all of them are almost getting through the 4 CPU cores. The memory is kind of weird. It's fine. Let me use a different way to visualize it. Let me use uh, a normal um, matplotlib. So let me use plt dot, or let me just do data open close the plot, and let's see. Okay, so we don't really see it that much. So let's do so plt dot subplots fixed size equals to, let's go by 15 by 6, and then let's say the sky axis of ax equal to x. I hope I didn't do the wrong thing here, bro. I told you. So let's see. I think it has no attribute. Oh, come on, dude. So let me check something right now. I will let you know. I'm just I think I've forgotten how it should actually work very well. Mm, so let me set SNS rather, um, instead of, let's do, instead of this guy here, let's just set this guy. Good. And you can see the kind of data we have. You can see that these are the prices on the left. So let me actually label the charts. Label charts. The PLT dot. Let's actually label the y-axis. The x-axis is actually, so that'll be price, and then the title that is um, stock. Let me say open and close, or opening and closing prices. So that's 20. So you can see that we don't really have, they are not really, really, what do you call it? Very, very, you can see, you hardly even see them. You can see, let me try. Maybe we can see them more this time. But let me leave them three. And you can see that they are blues, but it's like the orange line is actually covering the blue line. What it means is that this stock actually the opening and close pricing do not actually differ like that. They don't really really differ. So they are not like they are not like in this term we say they are not really volatile. So you can see that always the closing price is not really um, far away from the opening price. It is just by far away from it by some inches. And we can see it in the data set. If you look at this price, this is 368, this is 371, this is 369, this is 374. Sorry, this is not even the close. So this is 368, and then it closed at 370 just to 69, 3669, this is 374, this is 371, 360. So the prices are very close to each other. That is why you don't really see the lines like that. They are almost lying on top of each other, telling you that. So when you are a stock trader and you are trading in this stock, what you should know is that in this particular kind of stock, you will not get so much profit because the prices do not really differ. So if it's set at maybe one city, it wouldn't really go far from where it started. Now you can build. You can actually plot all of them differently to see. So for example, I can plot the opening price alone so that you will see. But normally we use a closing price for analysis, and then so we do DF. Sorry, it is actually data. I'm always used to DF. Let me do that. Close this time. Plot the let me see line width, a line width of 2. That's okay. Then let me label it, and I do PLT dot y label. And the y label is going to be price. Then the title is going to be, let's see, closing prices. And let me suppress the output. And if I plot this, so you can see how it is. So you can see how a time series data is. Time series data is this irregular, graph going up and down, some trend like some yama yama things. Now, the last time I told you about components of um, time series, we talked of trends, we talked of seasonalities and all those stuff. Now, if you look at this data set, for instance, you can see that when you look at the line, it is like from this side, from this particular from the start to the peak here, you can see that the line is slowly moving upwards. It is in an upward direction. So this one we say that it has an upward trend, because you can see it is from 2020 to 2020. Let's say around mid 2022. Yeah. So for 2 years, the price was actually going up, 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 up until COVID. So after COVID, prices started shooting down, 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 down. And then now, 2023, they picked again and they are on the peak. You can see that from here, from after the peak here to down here, to you can see that we have a downwards trend, meaning the line is kind of sloping downward. And then here is an upward trend. This is also an upward trend. Now, for seasonality, you have to pick one particular year and then see if there is some kind of movement, some pattern in it. Or sometimes you can see but this is not really, 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 let me say, clear. So if you have a very large years, a lot of years, then you would see a lot of trends. So this is just from 3 years interval, and that is why we don't see so much. So let's say it is from 1980 something to today, then you have enough data to tell whether you there is a very clear, and it will tell you, the chart will tell you whether there is actually some what do we call it, some kind of trends in there or not. Now let me try see again if this thing will work. For the plotly plots, always they actually have good. Glad this time it came. This is a plotly. So when you hover, you can see the date, the value, the date, and then its value. It's going on and on and on. And now one good thing I like about plotly is that you can just select a particular place and then it will zoom in there for you. So now you can see that here we can see the lines are not really lying on each other, just that they are really close to each other. So you can see that the closing prices and then the opening prices are very, very close. So if I zoom here, even here, you can see clearly that they are really, you know, very, very close to each other when they are not the same. If you double click, it will go back to the norm. Yeah. That is Plotly. So Plotly is a very nice 3D visualization. Something has a very nice interface. You can try that. Now we've known how to visualize this thing. The next thing I want to say is by how much. Let's see by how much does the closing price actually change? Let's say I bought it today. How much does it change? The price change because their profit is actually from by how much the price changes, from time to time. So if it is changing rapidly, rapidly increasing, a positive change, then you are also going to have profits. If today it is 10 cities, tomorrow it is 11 cities, your profit is one city. The next day it goes up, your profit increases. So every stock trader's dream is to trade in a stock which actually has a good what do you call it, which is highly volatile. And what we mean by volatility is that the price actually fluctuates. It fluctuates. It's not um, it, the fluctuation is also very, very high. So it can go up and down very well for you. Now let's check for volatility. So volatility and all these you can read more on online, and then we can do that by actually. So when we do data, and always when we're doing analysis on stock, we use the date, the close prices. So we have PCT. We have this thing called PCT change, a function called PCT change. And if you run this on it, you can actually see the percentage changes. So now if we multiply this by 100, then it will go to the official percentages. So a decrease actually means a negative means a decrease and a positive means an increase. Now, very soon let me add this to the data set and call it um, percentage change or price change. So let me call it, um, come on, let's add it to the data set and let's call it price change here. That is the change in price. And if I do data.head, you'll see it in there. Now this is a new feature we created. That's a price change. Now let me explain to you how did we come about this. That is a percentage change in price. So it is more like when we take the close, this is a value, this is the old value, and this is a new value. So percentage change will be the new price minus the difference between the new price and then the old price divided by the old price. So since this is smaller than this, we're going to get a negative number. This minus this is a negative, meaning that you can see that the old price was 160, now it is 158, so it has decreased. So negative divided by this, so the percentage it decreased by 1.245, 175%. So if you traded on this day, you lost this. So this is a percentage change. You can see from 158, it moved to 159 on the next day, and then that is an increment. So any positive number means an increment, and it is a percentage by which the price actually increased from the previous. And then it goes on and on. Some of them were even 1%. Now this, like I told you, is a big company system. That is Microsoft. So you don't expect a big company stock to be fluctuating very highly volatile. But if you pick, for example, a stock like Suzlon Cement or maybe Suzlon Energy or something like that. For example, if I come here and let's change the thing to Suzlon. So Suzlon is some energy company, um, Suzlon, for example, and let's see. Okay, so it tells us um, error why finance Suzlon except ticker blah blah blah. So let me go check Suzlon, or let's go check Suzlon's ticker. It's like we're getting the ticker wrong. So let's do Suzlon, Suzlon.ns. So that is New Zealand. So Suzlon Energy Limited on either Bombay Stock Exchange or New York or New Zealand Stock Exchange. So let's look at Suzlon.bo. That is the Bombay Stock Exchange. So Suzlon.bo, that is .bo. And let's see. So boom, it worked. Now if we check, you would see that if we plot the listing, for Suzlon, the prices actually do fluctuate a lot as compared to, and this one does not even really fluctuate. Let me do the one on NS and let's see. The goal is to more like show you more for you to understand the concept. Yeah. So boom, let's see. This is maybe pretty decent. Let's see whether. So let's plot and see if these ones are quite. So you can see how this stock price is like. This is also not really close. Maybe you can be trying them and then you will see a stock which is actually very volatile, and then you would use that one. When you use that one, you would see how volatility actually is. So if you have um, a highly volatile, what do you call it, stock, it actually gives you. Let's see crypto, for example, cryptocurrency. So symbol, we have a CMC 200, and then we have a lot of them. So let's look at CMC 200, for example. I'm doing all this to just open your eyes to it. It's not a matter of um, what was it called? CMC 200. I hope I got the this thing well. Okay, CMC 200 is in there. Think I didn't get it right. No time zone found. Okay, so that's fine. Let's go back to Microsoft. So when we go back to Microsoft, I was just trying to show you um, how well we can you know, go about things. And if the stock is highly volatile, you will see that the closing price is actually far away from they will not lie on each other like this. You will see that the blue line and the red line will have some distance between them, and that is a good sign for profit and also a bad sign for loss. You can easily lose. Now let's plot the percentage change and let's see. So let me just pick this line. I'm going to pick this guy here, percentage change. So I'm going to copy this guy and paste here, and you see we call it price change. I don't know why I'm using capital letters pro. Price change, and here we're going to do instead of this, let's be on the safer side. Price change. What did I do? It wasn't price change. It was yeah, price change. It is telling us, oh, okay, maybe we have to rewrite it again. Yeah. So you can see the change in price, how the change in price is. So you can see it is around, it's centered around majority of the spikes. The lines are actually centered around -5 and 5. But we have some outliers like -15%. So there was a time stock actually went down to decrease by 15%, and then there were times to it increased by 15%. And then, but you can see that the spikes actually lie between um, 5 and then -5. And let me just plot that and you see. So if I do PLT dot, it is a horizontal. So um, A, um, AX H line, and let's plot it on 5. And then let's say the color should be red, and then the line star should be dashes. And let's see if this one works. Yeah. So you can see that, um, let me put the other one to other. Instead of 5, let me make it -5 too. You will see that most of the values are actually between the most of the changes are actually between 5 and -5, right? So 5 and -5%. So let me change this to um, percentage change, and then this is prices change or price change, and then that is in percentage. Yeah, and this is awesome. So we can see that most of the prices change, or most of the volatility is between -5 and 5%, which is actually something very good to know. So this is to tell you that if you are to win or you are to gain a profit, it is not so much, or most of the times, about 99 or 90, over 90% of the time, your profit is going to be not, it's capped by 5%, and your loss is capped by 5% too as well. So, for one thing is, if you trade in these stocks, you're not going to make much within so much short time, but there is no so much risk to in losing so much, because these are reputable companies and they will not run at a loss at a quick time for you like that. Now the reason why there is a none here is that percentage change. So when you start at here, you cannot calculate the percentage change at the first day. So the percentage, we start from here, they start from the first day. That is why it is now. So we didn't calculate from there, because if you try calculating, it will be this minus it minus itself divided by itself. So that's going to be 0 over something, and 0 divided by something is actually not a number, or it doesn't exist. So that is why this is not. But from there, going, now we start to calculate for you. Now, enough of the talk. Let's look at how to actually model or build, a simple um, model to actually predict these prices for us. So we're going to build a simple auto-regression, model, that is auto-regressive integrating moving, auto-regressive model, and then later we'll look at how to build ARIMA. So ARIMA is actually auto-regressive integrated moving average, and so let me import them. So now for this thing, I'm going to import them from stats model. So this is a new this thing stats model. If you don't have it, pip install stats models. So from stats models.tsa.ar, that is auto-regressive model, I want to import um, auto reg. So auto-reg is a short form of auto-regression, and then it is a model for modeling, what do you call it? For modeling time series. Yeah. And then let's import Ariba too. So from stats models dot tsa dot arima dot models dot model import arima. And then now let's import some metrics too. So import from, we've not finished, model start models or graphics dot csa plots. We want to import plots acf, that is auto regressive plots, and then we have the plots pacf, actually plots pacf. Now the next thing is, let's import some metrics too. So from sklearn, the ones we know from sklearn.metrics, we want to import our mean absolute error, sorry, mean absolute error. And then let's boom, everything is all right. So let's go straight to the model building. Now before that, let's actually prepare the data for model building. Prepare the data sets for modeling. So now here, unlike the linear regressions and this, since this is time bound, and then always we have here we have just one, independent variable, just one variable, and then for a time series data, we have the timestamp as the index, and then the variable itself. So for this, the data is actually going to be, let me call it, maybe let me just call it x, a big X, and then it is actually going to be df, you know, close. Sorry, it is data. I don't know why I keep, so data close. That is a close price. So with a let's do exit head before I even continue. So with a time series, unlike a normal regression where we have features predicting, a lot of features, independent variables predicting a dependent variable. Here we are using, it's a time series, it is time bound. So we are using the previous, values to predict future values. So it is the same thing. We don't have like independent or dependent variable. The thing is depending on itself. So the price is depending on itself, but at different times. So we're using the old time, that was maybe yesterday, the previous times data to predict the next future. So you just, it's not like, so we just, sorry, we just pick what we want. And in this case, that is the time series we want is actually close. And you can see that it has the date and then the values. That's all we want. Now, since it's a time series data set, we have a way to actually um, split it. You cannot just split it using random split test, right? Or train test splits, a randomized way of the way we do for the other models. Here it is a time series, so it is time sensitive. So it is in order, more like, see, this is on the second, on the third, this is on the sixth, so on the seventh and then on the eighth. The reason why from on the third we went to on the sixth is that third March was actually, it might be a Friday, and then fourth, fifth, sixth, fourth and fifth would be Saturdays and Sundays. You don't trade stock on weekends. So that is one thing you should know. So that is why some of the data sets, like some days are missing. Those days are the weekends and then holidays. So we don't trade stocks on holidays, we don't trade stocks on weekends. So otherwise you can see that the data is in a format. So we have to cut the data in such a way that it's preserved that, continuity. So to do that, we have a special way of, cutting called, actually, we don't just split, but we actually kind of like slide, kind of like slice, like a slide of, or whatever, a slide of bread. How you cut it? You cut like, and then leave the other, something like that. So let's look at how to split. I forgot my title. Let's do split data sets, and then we're going to do, so the data is X. Now, how we're going to do is we're going to use 80% for training, 10% for testing. So instead of doing train test place, then this is this, we don't do it that way. So we're going to actually cut with time sensitive. So we're going to say that okay, now if you do x dot shape, you say you will see the number of rows, right? So if I do x dot shape 0, it will give me the number of rows. So now for me to know 90% of it, I'll just measure and multiply this by 0.9, which is 90%. So if I multiply this by this number, it gives me this. So if it is actually a decimal, so to convert this to an integer, I actually wrap it with the int function, and it will convert this into an integer for me. So it will run it up for me. So now this is the integer. So what we have to do now is, now this is a cutoff point. So we call something like, let me call it cutoff. So the cutoff is actually this number. So how we're going to do is that, so first we're going to say, let's say, let's call, so x train is actually going to be the x, that is the data, but we're going to use a iLook. So the iLook is like integer location. And then we're going to say that go into the data set, give us everything, in the beginning till you get to the cutoff, point. So more like from the first date till the 890 feet, object. Then keep that for training, and then the testing is actually going to be, let's say, X text, or let me just call it, since we let's call it train and then test. So the test is actually, the testing data is actually also going to be the data itself, and then we want to go into the data set. I'm saying that hey, now since this was give me everything everything up to 895, the testing data will be from the 895 going. So it is going to be cut off going. So cut off colon, saying that cut off to the end. So the colon here is telling Python that, remember when we're doing list, um, how to um, access elements from a list, we looked at the referencing using range. And I said that if you give an index number and then the index is actually something like we give, and then you give a free range before the colon, it says that start from where it starts, and then the same way if the right hand side of the colon is not given, it says that to the end. Now if we print, let's try to print let's try to print training data set shape, and then let's say train.shape, and then let's do testing data sets shape, and let's do test.shape. You would see that um, oh okay, I spelled this wrong, guys. I look should be spelled right. So you can see that 895 for testing, and then for training, and then these ones for. So if you look at, for example, if we look at training or train dot tail, the last object here, it was on the 2023 July 24th. Now, if I go and do testing or test dot head, where the testing data start from, the first, you can see that it's a continuation of this. You can see that it is 25th. So it is like we slice it in taking time into consideration, because this is a time series data, so it is time sensitive. So that is one thing you should know. So we can see that this is actually a continuation of this, and that is how we actually cut or split time series data. And then now let's go straight into building the model straight away. We're not going to waste much time, and let's just go right into it. So um, before that, let's calculate the mean, like a baseline. You know, let's calculate a baseline mean absolute error, so that our model will know, we will know if our model is performing better or not. So the baseline mean absolute error is actually going to be like the mean of um, the mean error of the mean against the actual values. So we have to calculate the mean. So the training, or let's say mean, will just be when we do training. If you want to know, if you do training or train.mean, it will tell you the mean, the average of everything in there. So 200 and this, and then let's assign that to um, the variable mean. So we want to make this um, as long as the data set, the training data set, so that we can actually calculate the mean absolute error. So we would put this actually in a list, so that it can be like a list, and then we will multiply it by the length of the training data set. Or in other words, we can do um, we multiply it by actually cutoff, because cutoff is a length. You can see we did cutoff up here. That is a 90th this thing. So when we multiply it by that, we will have the same length as the listing. And then the baseline, let's call this baseline mean absolute error, baseline MAE. That is going to be mean absolute error between the train, that is the training data set, and then the mean. That is the mean of the listing. So now let's print. So let's say the baseline MAE for mean absolute error is, and then let's do the format, and we will do baseline MAE the round. Let's run into four decimal place. Let's see. So I have an error here. It is that the name train is actually not defined. So you can realize I didn't spell train wrong. So I have to be good at writing. So we can see that our mean baseline mean absolute error is 39.9723. So we have to build a model which has a mean absolute error lower than this. And then how we calculated the mean absolute error is that we just found the mean of the training data set, and then we multiplied that by the number. We just what for the mean absolute error, we the predictions and then the actual distance should have the same shape. So after calculating the mean, we just multiply it by the size of the training data set, so that they kind of become the same. Then we calculated um, the mean absolute error between them. You can see it is 39.37. Now let's build the model. So when we build the model, our goal is to have a model which performs better than um, which performs or which has mean absolute error than that. So build AR, that is auto regress, or let me auto regressive model. So now since we don't know since we don't know, the autoregressive model actually takes um, one function called lag. The lag is actually the what's up?
Please, you see the second line, you said mean is equal to train.mean. So that's the mean for the training data. Please, the other mean, I
Which one?
don't understand. The second one, the second line.
This one.
Yes, please.
So it is just so after calculating the mean, like if you want to calculate mean absolute error, the prediction should be of the same length as the true values. So the mean is just one number. So I'm multiplying, the cutoff. If you come up here, it is actually the the cutoff is actually the length, the value we use to cut the data set. So that is the length of the training data set. That is this. It is 895. You get it? So the training data set has 895 observations. So I'm saying that now multiply the mean, that mean we calculated, by 895, so that we have 895 times of it, so that we can match it with true labels and then calculate the mean absolute error. Is that cool?
Please. Okay.
Okay, I'm glad. I didn't even know you are the only one left here. So that's fine. So let's just go. Everything is fine. So when you want to build an ARIMA model, what you have to do is one thing you have to, oh sorry, autoregressive and error model, we provide the lag. The lag is the timestamp. So either is it 5 days? Should we predict using 5 days range, a day range, 2 days range, or whatever? So since we don't know which one will work best for it, I would like us to do something like a hyperparameter grid search to see which one is better for the model. So let's just do um, let's do a for loop to kind of like do. So I'll set the lags and I'll be like, so lags actually equal to, let me give a range. So a range of 1 to 11, that is 1 to 10. Python actually does not include the last one. So 1 to 11 is actually going to. So if you print lags, you can see it's okay. It's not really going to show, but it is a number range between 1 and then 10. So Python for a range, it doesn't include the last value. So what I'm going to do is I will say that for lag in labs, I'm going to use a for loop for lag in labs. I want to build a model, and then the model is actually going to be the autoregressive, that is the autoreg model. And then this is how it is not like scikit-learn. We don't train it like scikit-learn. So with this, if you instantiate the model, you have to pass the training data set into it. So the training data set is actually the train. That is a train. And then the second value you have to provide is a lags value. So the lags is actually going to be that particular lag. So if it is a lag one, it should be, so it's going to look through start. If the lag is one, it should fit the lag one and then go. So now if it finishes, so this is how we do it. It's not like scikit-learn where you do dot fit and then you provide the training data in here. So with the stats models modeling, or how we build data, or we build models in stats models, we or using stat models, we actually pass the data, the training data, to the model itself, and then just do dot fit with nothing. Unlike the scikit-learn code where dot fit and then you bring. That's what you have to do. So now to make predictions, we have to call that we do model dot predict, and we don't provide anything in there. We'll just do predictions. Which it's going to predict the training data set for us. It's going to predict each timestamp for us. So I want to store that in this thing called YPRED, and that's going to be model dot predict. So that is the prediction of the entire training data set for us. And then what I'm going to do is I'm going to calculate the mean absolute error, and I'm going to store it in a variable called MAE. So mean absolute error, and then it is actually going to be so I'm going to that is going to be the training, the mean absolute error between the training and then the YPRED, that is the predicted values. And then what we want it to do is that we want it to print. Now it should show the print. Sorry, you should actually print the this thing. So something like for lag, let's say whatever lag it is. the mean absolute error, that is MAE, is it gives us so that we know, okay, this is actually the mean absolute error for lag 1, and then so we go into format by lag and then MAE. Now that's it for the training loop I'm creating. So we can see that, okay, there is an issue here. It contains nouns. So what we're going to do is that, you see, very soon you will understand. But how to solve this is to actually say that now here we have to provide lag dot this, and then here too we have to provide something like this, lag, yeah. And the reason is, when it lags, come on, um, okay, come in. Let me check it very well. Maybe something is missing somewhere. Mean absolute error, and it is saying that it actually has some, it contains NAS. So let's unpack this and then see what it is. So let's actually, so if I copy this here and then let me bring it here, paste, and let's say I set the lag to say 2, and let me go and pick this guy here, the predictions, and then come in with predictions, and let's try to output the predictions. Now we can see that it actually has just, so it's saying that um, a date index has been provided, but it has no associated frequency information, so we would ignore when forecasting. Example. Okay, so to solve that, we have to provide a frequency to say, is it daily, or is it I think it is freaks, if I'm not forgetting. So let's make it D and let's see. I think it's actually freak. I am forgetting this. Let me check quickly and then I'll get back to you. So um, before that, let's try to convert this thing to a date type. So let's do, let me just try something out and see whether it works or not. Or let me also try a different way of training the data set instead of, um, so before that, let's try and see this. Maybe the video data, the info, maybe the index is not actually in, all these guys are in there, but let's look at data.index. It's actually date time, but we don't have the frequency since some of them are actually missing, so we don't really have a frequency. Now let me go and read the documentation, then see how to solve this. Give me a second, and you can also do a quick search, and then we see how to go about it. Right. I have a way to go about it, but I really want to um, um, go by this way so that you see. I have a way to solve it. I think I feel more like if I go by the normal approach. It will help since this is most of us our first time of doing it. Yeah. We can just pass the values in there and then we would provide a time step later. That's not a good thing. So so let me see. I think I'm seeing something. Maybe it's gonna help. And I'm gonna give me just few seconds and I'll get back to you, right? You can also search. Maybe your search will be faster. I want to read the documentation and then see. Um, yeah, Rama, you can go ahead. Okay, it was like okay, sure. Let me try. Okay, let's try see if it's going to do. Sometimes these things happen. It is because the data set actually has some kind of you know missing data in there, missing days in there. So it's kind of finding it very difficult to um, so let's do a lab of one and then let's see. It's actually finding it very, very difficult to. You can see it is just providing num values. And let me see how we can actually let me see how we can actually go about this. If I don't find any this thing, I'll just do something and then we'll be good to go. Okay, I saw something here. Let me see whether it works. So let me just try lab 2 and then set index equal to so I see from Stack Overflow and index. And let's see, and then it doesn't work. So this is actually not true. So let's look at this is my way of solving this. So if you want to solve this, let me see, I hope it works. So what to do is instead of um, providing just a data set, provide the values to it. And you can see it's now it's now predicts very, very well for us. So you can see that since it's a lag of 2, we would actually have none for the first two things. So we're saying that use the two timestamp, like 2 days interval to predict. So you can see that the first two. So if the same way, if you change the lag to say 3, it's actually going to give us that. So now the problem is solved. Let's go back to where we came from. So we can just train with the values. So the training data set values, and then what we're going to do here is we maintain the rest, and let's see if it works. And okay, it's actually dot I did. Um, so you can see it. So you can see that. So it has finished training. So for lag one, the MAE is actually 3.624, and then okay, so let's let's round it to 4 decimal places for easy. So with lag one, we have 3.628, and then we can see 3.631, blah blah blah. So when we check, they are not really, or maybe let's increase it to maybe like 20, or let's say 30 days, since we have 30 days in a month, and see. And we can see that they are just so much around there. They are really around the same thing. So let's say we're using actually lag of, we are pleased with lag of 29. So you actually use a lag which has the least mean absolute error. So in our case, let's just say we want to pick the lag of 29, for example. Or maybe you can increase it to C, for example. So if I increase it to, let's say, 35 days, let me see whether I'll get a decent one. And you can see that, so after here, after 29, or after, let's say, yeah, after like 29 days, it starts to freak out. Like it starts to, the mean absolute error starts to go up. The 29 is the ideal, this thing. So what we're going to do is to build a special AR model using the lag of 5. So all we're going to do is just pick this guy, just pick him, or let's just pick these guys, and then so we actually, so we're going to build AI AR29 model that is the best model according to the mean absolute error, and then it's simply going to be, we will just change the lag, go to lag to equal to 29, and that's all. And then we have to index this wall because it's no more in a for loop. And then if we print y pred, we print y, sorry, we're going to have an error because I accidentally added. So we can see the values in here, very nice. Now let's do one thing. I want us to check the prediction and compare them with the actual, actual values. So to do that, we would actually do um, to do that we would actually convert the whole thing into a data frame so that we can plot. So, um, convert predictions to a data frame. So what we're going to do is we're going to do pd.data frame, and this data frame is actually going to be um, it's going to have a dictionary. So we're going to create a dictionary, data frame which is actually a dictionary, data frame from a dictionary. And in the dictionary, we're going to have true values. Let's say true prices, yeah, or true price. And then the true price is actually going to be um, the training or the training data set. Since the lag is at 29, so we're going to start from 29 going, right? So meaning that we want to start from the 29th item, and then the next thing is actually going to be um, the predictions. So we're going to say that okay, if that is the case, then predictions or the predicted price too. That is the prediction our model made. It's actually also going to be widespread. So by this, they're going to have um, the same distance. This is a time model. We set the index equal to the index of the data frame is actually going to be the training data, the train dot index. We're going to start from um, 29, the 29th, the, um, the 29th observation going. And if we run this, we actually get error. It says that compiler blah blah blah. So let me check. Let's check well to see what's the problem. So the whole thing is since the widespread 2 has some missing, data sets in there, so we have to also start that one from the 29th, and then I think it should solve, but it's not solving. So let's try to see something. Okay, actually, instead of doing training, let's do training of values because we just want the values, and it is still not giving us what we expect to get. Okay, so it's simple. Here we should have given a column, and we give a comma. See, so you can see index very nice. And then this is so for example on the 2020 13th of February, the true price was 183, but our model predicted 184. So now let's try to visualize this to make it very nice. So we're going to visualize predictions together with title. So we're going to visualize our predictions together with the true values. So we will have using today we're going to use a lot of plotly. So we're going to plot align this thing and boom. Sorry, I didn't actually assign this to any this thing, any data frame, any variable. Let me call it D, and then let me do so D dot head to get the first few observations, and then so the data frame is actually going to be D, and then the title, that's all we need, is going to be the performance. It's actually showing the performance of the model, which is actually AR29. So AR simply 29 is to say the lag, and then when we do, so we actually have to assign this to fig so that we can show it. And then when we count down here, we just do fig to show, and let's hope this is going to show. Yes, so this is actually, so the red line is actually, you can see the red lines are actually our predicted prices, and the true prices are actually the blue lines. And you can see predicted prices are very, very close to, you know, the, are very, very close to the, what do you call it, um, to the red line. Now, if I zoom in here, see, you can see that they are very, very close. Let me even zoom here. You can see they are very, very close. For example, this was actually we predicted 187.68, but actual value was 186.74. So you can see the difference is very some small coins, and that is very good. So we've built a model which actually really performs, and always when you double click on the chart to go back to the normal, which actually performs very, very well. It has studied our data very, very, very well, and it is predicting values very, very close to the model, so to the actual value. So if you are using this model to forecast, you know, let's say you trade and you are using this model to forecast your um, future prices of the stock, it is actually going to do well for you. Now, with that being said, let's look at how to actually forecast future values. So, so forecasting is more like forecasting future values. Now we are actually just testing what we have, but let's forecast future values. So forecast, that is what we don't know, probably tomorrow or something, future values. And then this is how we're going to do. I think in the afternoon I wrote a function somewhere and go and look for it, and so that we are running behind time, so that we can actually use the function and we will be good to go. So let's create a function. Simple. So always function is okay. Um, so let's call it forecast price, right? And then it's going to take the start date. So that is the date you want to start, and then the forecast. That is the forecast days. That is the number of days you want to. So let's say you provide today, the start date is today, but you want to forecast 7 days. That is, that is the forecast days. And then we want to give which model you want to use, and then let's set it. So our model is actually going to be model. That is a model we've actually created. That is a default value. So you don't even need to provide. Now, the first thing is to actually um, pass. So pass the start date is more to say more like convert the string the person is actually going to provide into a date format, so that Python would actually understand it. So we that is what we mean by pass. So pass as in, so we're going to pass the start date, that is to convert it into the format date time or date format. So pass the start date, and then you will say that start date is actually date, you know. So before that, um, let's import date time, so that date time is what we're going to, and then we import time delta. So time delta is what we're going to use to infer the we're going to use to infer um, whatever. So if you say you're starting today, you give 7 days. What we're going to use to generate the rest of the days for you. So the start date is actually going to be date time dot strp time. That is the function SPR time, the E didn't come. The function actually um, to actually get to actually convert it into this thing. So you want to convert the start time before right into start time, and then the format is actually going to be um, year. So percentage. That's how we write it in Python. Dash percentage small m for month, and then dash percentage um, D. So meaning year, month, day. So when we have this, now the start date you provide is actually going to be in a date format. Now let's generate the rest of the dates, the rest of the dates for the days the user provided. So here now you've provided, let's say, start date today, and then you provided 7 days. So now what we're going to do is, oh sorry, here I didn't really do it well. I have to do from date time, import date time, and then time delta. So you provided a particular date, start date, and then you provide 7 days. So we want to generate the date for all the 7 days. So um, let's call them, let's say, dates. This is a forecast date, and then that date actually going to be, we're going to use what we call list comprehension. So we're going to say that start, sorry, I don't know why my hands. So start date, that is the start date you gave, the one we've passed it in this thing, plus time delta. So time delta is actually, so days equal to I. That is this thing for I in the range, actually forecast days. That is all we're trying to do is, this is a list comprehension. That is why I put it in a square bracket. So what we're going to do is that, so for I, so let's say you provided 7 days. So for I in range, forecast this, it's actually going to generate, like, let's say you provide 7 days, that's going to be 1, 2, 3, 4, 5, 6, 7. So 7 dates. Now with the 7 dates, we're saying that the dates are actually going to be a list, but the start date is actually going to be, so with the start date, you actually add the day. So if we start at, let's say, today, then the next day is going to be, so now I is 1, the first iteration I is 1. So it's going to be, it's actually going to be days is equal to 1. So it's going to be plus this date you see here plus 1 day. So it will loop for 7 times. So if it is 24th plus 1, 25th plus 1, 26th, 27th, until you exhaust the forecast dates. So now that you have the forecast dates, what we're going to do is to, you have to forecast prices. So let's forecast prices for each day. So let's call it forecast. Let's store that forecast in the this thing, and then that's going to be model.predict. That is, the model is going to predict, and then we will say that the start, that is, that our model has start. So start is actually going to be from the start date, and then end is actually going to be, the end is actually going to be the dates. So the dates we actually provided, the last day, you know, of the dates we actually generated. So when you gave 7 days, the last date is actually going to be the end date. So we're inferring that. So now when we finish that, the next thing is to actually create a data frame, and then, you know, give you the output in a data frame. So we create a data frame so that it will be easy for the person to see. Create a data frame to, um, or for the values, something like that, for the forecasted values. And that is going to be, so we will call it df, for example. So the df is actually going to be um, pd dot data frame, and we have a listing, and simply we will have dates. So we will have the dates, that is the dates you provided, or date, simple. And then the value is actually going to be the dates we generated. And then we would have price, or stock price for short, because we know we are predicting stock price. That is actually going to be the forecast we made. That is the forecasted values we actually made. Now, when we finish that, what we're going to do is, since it's a time series, we want the index to be a time. So we have to set data frame index to the date. So we make the data frame index the date. That's what we do is, so df dot You will say that df dot set index, set underscore index, and then we will say that we want you to set the index to be the date variable we provided, and we set in place equal to true so that it would override any other thing. Now, when we finish, the rest of the thing left is to return the data frame for the user. Now, I hope it works. Now, let's try the function. And then it is actually, okay, let me, this and this shouldn't have to. So to try the function, let's call the function. So forecast is actually, so forecast price, forecast price. And then the start date, so I'm going to give a start date. And then the start date is actually, so it is a year month day. So I'm going to say 2023, um, December 15th. And the next thing I want to do is the how many days I want to forecast. So forecast days, and I want to forecast five, let me say 7 days because I know the weekends are actually not. Or let me start from Monday. And I'm what day will be Monday? 18th, right? This is 15th, 16th, 17th, 18th, right?
Yeah, yeah.
Okay. So I want to forecast 5 days. That is from Monday to Friday. That is what I want to forecast. And if I run, if you don't get any error, you have an error. Let's see. So the error is saying that the start argument could not be matched to the location related to the index. Okay, so the whole issue is since we didn't train the data having any indexed in there, what we have to do is to actually define the function in another way. So what I did was in the afternoon when I was building this, I actually managed to build using the timestamp. So now since we don't have a timestamp, we have to override the whole of this, but I'm not going to clean it just like that. It can be used for future, maybe in your future this thing it can help anyone. So let's call this function two. So function two, like an alternative. Yeah, let me even add it to it. That is like alternative. And then this alternative is actually going to be simply, so let's still copy this top here, this guy here. And then, yeah, I mean, let's actually call these guys. And what we're going to do is we will just ask start date, right? So we will ask you the start date and the forecast days, fine. But when we ask you that, we will pass, yes, we will pass we will convert the start date into dates for you, all right? And then we actually going to generate, we're actually going to generate this, all right? But when we come here, so the only difference we're going to make is something very simple. So when we come here with the how we forecast the prices, instead of using model.predict, we're going to use model.forecast. So forecast is actually a way to forecast the values. So we're going to say instead of doing the listing, we're going to say the forecast is actually model.forecast, and then the forecast takes the steps, you know, function, and the steps is going to be the forecast. That is the number of days you want to forecast. That is going to be the forecast days you actually provided, in the function. So when you do that, now when we come here to build the data frame is actually going to be something like this. We actually going to um, we're actually just going to build. Let me. I don't want. I want to be lazy. Let me just take this guy, clean it. I mean, format it to suit what I want to do. I hope it works. Or is it something silly I'm thinking of? So all we're going to do is, so now instead of bringing the dates here, we're just going to ignore it for now. So we just give the prices are the forecast. Now outside of the dictionary, you will set index actually equal to dates, the dates we actually generated. And then when we finish that, I think we should be cool to, you know, return the DF. So let's hope it works. I hope this one works. Boom, and it works. So now we've been able to generate um, forecast stock prices for um, 2020, 18th of December 19th, 20th, 21st, and then the 25th. So that is um, next week. These are the stock prices as predicted stock prices for um, we use Microsoft, right? So Microsoft for a period of for next week entirely. You can see the dates there, and then the prices very nice, and it's really awesome, right? It's really awesome. I think I love it personally. I hope you love it too. So now you can go ahead to maybe build, or anyone who will watch later, you can go ahead to build a function, a simple function. Uh, you can deploy it in Gradio. I mean, that's what I want to mean. And then you have a nice interface, and you can so you can see that now if I change this to maybe 7 days, you can see that boom. So 23rd, it even predicts Saturday's price for me, forgetting that Saturday is actually a holiday. A holiday. So if you want to make it more robust, you can actually add that into it. If the date falls into a weekend, it shouldn't predict. Or you, the human who is using, should know that we don't trade stocks on weekends, so you don't do or when it's on a holiday. But you can actually build it, improve on it to do that. And you can. This is very awesome. You can try it on a lot of things, and I think it's worth it. I love it personally, and I hope you love it too.
Yeah,
You see, it's really awesome, like working with some of these things.
yeah,
Yeah. So now the one thing I want to say is that with the lags, we have ways to. So you can use a PACF plot, you can use the ACF plot to actually, you know, do that. So with the PACF plot, so let me do. So the PACF plot is actually to determine. So if you want to do that, you just do plot underscore. Yeah, remember, we imported PACF plot PACF, and then you provide the data in there. So we actually want. I think we provided X, right? So we want to do. I think it was train. That is the training data. So we want to know the best um, P value or the best value to choose for the lag value. That is the P. So if we do this and plot, it would give us some yama yama plots like this. And now, one thing you have to know is this is just very simple. These bars, you see, there is this blue line here. So the lag you should choose is actually the bar or the line or the yeah that stick that falls the first line that falls between the blue, kind of like the blue bar along the axis. So you can see that this falls within it. This is the first one, and it is actually, so if this is 0 and this is 1, this is 2, this is 3, this is 4, and then this will be 5. So it's actually 2. So meaning that 2 days going, after 2 days going, the values have the power to detect, um, to predict the future, or they have influence on the future values. So we can build an ARIMA using two. You can see that after the two, all of them are within the, the, what do you call it, the blue beam. So it is telling us that after 2 days, the previous prices actually have greater influence on the future prices. So if you don't want to do any hyperparameter tuning like that, Alex, I did writing a for loop to waste time and all those things. You can use the PACF plot to choose the okay, to choose a value for that. And that is it for now. We've wasted a lot of time due to time factor. So if you want to plot the ACF2, you just do plot ACF instead of plot underscore PACF. You just do plot ACF. So the ACF2 has what it is used for. If we were to build the ARIMA model, the ARIMA takes three um, lags, that is PDQ. The P value, we use a PACF plot to check. So if the P value would have been, so let me finish this. The P value would have been the, and actually have been this guy here, this the first value or the first line which falls in the beam, and after which all of them falls in the beam. You can see that that is this guy, and it corresponds to, I hope you can see that. And then the MA, that is the Q value of the ARIMA, is actually used, um, is actually or let's say it's actually predicted by or used, determined by the ACF plot. That is the autocorrelation plot. And then you can see all of them are outside. So telling you that the MA is actually, so with this one, it means that the MA should be zero, because, or you have to do some differencing because they correlate to themselves even some for some long distance. So you can see all the bars are outside. So with this, it is always good to use auto-regressive, that is the auto-reg or the AR models like we've just used, and forgetting the MA aspect. So if you want to know more about that, probably when we meet again, we will throw more light on that. But you can also read a lot of great resources online. You can look for books, you can look for articles, you can look for videos on YouTube, and a whole lot. Yeah, you can even use ChatGPT, the GPTs to teach you more. So this is it for today. I don't want to waste much more time of you and Amwa. And thank you very much for staying with me through this. And I would like to take your questions here if you have any.
Please, I have no questions.
Okay, that's cool. So if you try and there's some questions, you can let me know. Right. Thank you so much for coming. I'll see you